This Zoom session is being brought to you by the Fractal Bullseye Bubble Water. All right, for today, 4-4 and 4-5, if I recall correctly. We got to 4-3 last time, if I recall correctly. Now 4-4 about logarithm laws, and 4-5 exponential and logarithmic equations. Now, basically, a lot of these logarithm laws are basically exponential laws written backwards because they're inverse operations. So b to the 0 equals 1, therefore log base b of 1 is 0. B to the first is b, therefore log base b of 1 log base b of b is 1. And here logarithm and exponential are inverses, so log base b of b to the x is x, b to the log base b of x is x. Okay, fine. These, of course, can be found from these. And because b to an a plus b is b to the ab, no, sorry, b to the a times b to the b, whatever. So in other words, exponentials turns addition into multiplication. Logarithms turn multiplication into addition. Log base b of xy is log base b of x plus log base b of y. Exponential of a difference is a quotient, therefore logarithm of a quotient is a difference. B to the x times y is b to the x itself to the power y, so exponential turns a product into a power, and conversely, logarithm turns a power into a product. And from this last one, what follows what are called the change of base formulas. Log base b of x can be written as a ratio of common logs and natural logs. Natural log x over natural log b, also log x over log b, common log x over common log b, and in general, log base a of x over log base a of b. You can find derivations of these formulas in the textbook. So here are some examples. We have log of 7c over 2. They asked to simplify it. Well, the idea is that logarithms turns products and quotients into sums and differences. So this will be log of 7c minus log 2. The 7c, we break them into log 7 plus log c, and all that minus log 2. We have log of x to the third y squared. What's that? Well, logarithm turns this product into a sum, log of x cubed plus log of y squared, and it turns a product, a power, which is a repeated, a power which is a repeated product, into a product which is a repeated sum. So log of x cubed is 3 log x, all that plus log of y squared is 2 log y. Here we have log base a of cube root of x times 4th root of yz. Now we're going to get a little bit of a complication here because we're dividing by 2 variables here. So, okay, this quotient turns into a difference, log base a of x to the 1/3 times log base a of yz all to the 1/4. So I write a cube root is a 1/3 power, a 4th root is 1/4 power. Bring out the 1/3 and the 1/4 here and here. So 1/3 log base a of x minus 1/4 log base a of yz. Now here where things are a little tricky, I have to be careful. Log base a of this product is a log base a, is a sum of log base a. So 1/3 log base a of x minus a quarter of the sum log base a of y plus log base a of z. Now you have to watch out, be a little careful because you have to distribute the -4th. And that will mean this sum turns into a difference. So 1/3 log base a of x minus a quarter log base a of y minus a quarter log base a of z. It's important to have this minus here. I've seen quite a few people go from here, start from here and just somehow drop the parentheses as you get plus a log base a of z, which is incorrect. The z is in the denominator, therefore its logarithm is subtracted. All right. Log base 5 of 1 to the t cubed all to the power d. What's that? Well, okay, the d comes outside. D times log base 5 of 1 over t to the 3rd. 1 over t to the 3rd is t to the -3rd. So the -3 comes out and you get -3d log base 5 of t. Here we're going to write it back, go backwards. We're going to take a sum of logarithm and turn it into a logarithm of a product. -3 log base b of x minus 2 log base b of y plus 1/2 log base b of z. What's that? Well, the 3 goes inside, the 2 minus 2 goes inside, the 1/2 goes inside. So you get log base b of x to the -3 plus log base b of y to the -2 plus log base b of z to the 1/2. Then we multiply these sums turn into a product. Log base b of y x to the minus 3, y to the minus 2, z to the half. And then for a last step, these negative exponents means positive exponents in the denominator. And a half power is a square root. So log base b of a square root of z divided by parent x to the third y squared and parent. Now here we have used the change of base formulas to estimate log base 3 of 7 and log base 3 of 8. Log base 3 of 7 is a ratio of log 7 over log 3. Log base 3 of 8 is log 8 over log 3. And okay, these have values. Log 7 is about 0.845098. Log 3 is 0.477121, whose ratio is about 1.7712 to 4 places. Here, log base 3 of 8 is log 8 over log 3. That's 0.9030989 all over 0.477121. And this is 1.8928 to 4 decimal places. Here they ask for log base 4. I really should write this as 11 to the 4th. Make this 4 a little smaller. It's potentially confusing. This is 432, 434, 11 to the 4th. No, and not 114. That's a danger of this notation. B is 4 log base 2 of 11, and C is log base 2 of 11 to the 4th power. Okay, well, A and B are equal. The power of 4 becomes a product outside. These two are equal. This is an entirely different critter.